This is going to cover how we're going to prove that triangles are congruent. So one of the ways that we can do this is by using what's called the side postulate. And what this says is that if we have three sides of one triangle and they're congruent to three sides of another triangle, then the two triangles have to be congruent. And so here are three sides. We've got this blue one to the blue one, the green to the green, and the red to the red. And this is called GeoGebra. It's a free program that you could use. Um, and what we can look at here is that our sides are congruent, right? We've got 5 and 5, 8 and 8. Oh, sorry, 8 and 8, and 6 and 6. And if I try to combine those sides, right? So I can change my angles, but I can't. If I try to move this and make it shorter, it doesn't let me. That side has to stay the same. So those are my given side lengths, and the only thing I can do is change my angles to try to make them meet. There we go. And so when they're matched up, you can see that the angles end up being exactly the same as well as the sides. And so that shows us that when I do that, I can make only one triangle. It might be rotated or flipped, but it's the exact same triangle. And so side shows congruence. Here we've got included angle, and this is just to point out what that means. So the included angle is the angle that is inside the two sides that we're talking about. So if I say this one's congruent and this one, to a separate triangle here, then this angle that is between these two is called the included angle. And that's important because we can talk about side, angle, side, and when it's written like this, the angle is included between the two sides. And when it's written like this, side, angle, this angle is outside of the two sides, and that makes a big difference. Okay, so here, this angle is included between the two sides I'm talking about, and this one is not. So side, angle, side is also a postulate that proves that they are congruent. I've got these two green sides that are congruent and the blue sides that are congruent. And this red angle is in between the two sides, and that also proves congruence. So here I've got the side 6 and 6 are congruent, right? 7 and 7, and the angle in between them is 97 degrees here on both of them. So these are my fixed things that cannot change based on what I've been told. But I can change this angle, I can change this angle, and I can change the length of this side. So if I try to bring this to meet over here, then the only way I do that is when these angles end up being the same and this side length ends up being the same. So it shows that they're congruent. And so this one is angle, side, angle, where I've been given two angles and the side that's in between them. So this side is the included side between the two given angles, right? So I've got this one, it's congruent to this one, the pink angle with the pink angle, and then the side in between them. And you can see that here, these green pieces are the given ones where we've got the two angles, and then the side in between. And then I try to line these up. And when I line them up, you can see that all the measurements are the same. Okay, so side angle is not a congruence because we can make two different kinds of triangles here. So here I've got this given side and this given side and this angle, which is not between them, right? This is the non-included angle. And you can see that that one leg can move, okay? And we can look at it here as well. So I've got this side is given and this side is given and this angle, but that means this angle in between can move and the length of this side can move. So if I, whoops, if I move this side and I change the angle of P, the degrees here, right? I can end up meeting this line here to make a triangle, or I can keep going and I can make another triangle there. And you can see that this one and that one are different triangles. So if I have the side, and the non-included angle, it does not prove that the triangles are congruent. This is just an example of the ones that some of the ones that we can use and how you might see them, okay, with the markings on them. And then this is another version that's kind of color coded. Um, we haven't talked yet. I didn't talk yet about the angle side. And really, this is just, it comes off of angle side angle. So if I know these two angles are congruent, I also know that this third one is, right? Because they have to add up to 180. So if two angles are congruent, then the third angle also has to be congruent. So all of these ones work. If you can show these to be true, then you can prove that triangles are congruent. And yeah, let's do this. So these are kind of the different ways that we can arrange these. So we have this is the same as AAS. It doesn't really matter which one you do. So usually we say angle side, but if you wrote side angle, it's fine. And we know that, oops, side angle doesn't work, right? That's the one that I showed that the leg can kind of move back and forth. Angle also doesn't work because I can have a really small triangle and then I can make it really big and they'll be different sizes. So that does not show congruence. And that's the side angle that we talked about. Okay, so those are my 4 that I can use. Reflexive property, this is sometimes how we write proofs. I'm not going to spend too much time talking about two-column proof right now, but the reflexive property is a reason to show, to be able to explain how we can prove something. And I'm going to use it here. So in this picture, I can show that AB is congruent to BD because of these marks. And AC is congruent to CD because of these marks. Okay, and you'll notice here I color coded it so that these ones are black and these ones are red because these are all part of one triangle. They're the one up top, and these are part of the triangle on bottom. And then I'm going to say that BC is the same as BC, and that's that reflexive property, or I should have written this on the thing. Or you could say that they're the same segment. Reflex. Okay. But I need this third side to show congruence. So I've got AB is congruent to BD. That is one set of my sides. And then AC and CD, that's my second side here. BC is this third one. And then it shows that these two triangles are going to be congruent. Notice the way that I wrote my letters. AB here. Let's maybe try to change. So AB and BD are congruent and they're together here, right? AB is my first 2 letters on this triangle, and then BD is the first 2 letters on that triangle. That's important.